All right, let's jump into the section 4.4 notes where we learn pretty much everything we want to know about logarithms. So we did some graphing previously, but we'll also need to evaluate logarithms, and we'll need to be able to work with logarithms in terms of rewriting them in different ways, condensing, expanding, and we're going to learn all about that in this notes video. Okay, so the first thing we'll do is evaluate logarithms, and really the key to evaluating logarithms is what I'd like to call getting the same base. Okay. If we can do that, there is a very simple rule for evaluating the value of a logarithm. Okay. So if we have a logarithm, let's call it with base b, b for base, as long as the quantity of the logarithm also has a base of that same number to a specific power, let's call it the a power, this is equal to that exponent. Okay? So for instance, log base 10 of 10 is equal to 1. Why is that? Well, we have a 10 as a base, the 10 as the quantity, this is raised to the first power. How do we evaluate that log? It is equal to 1. Okay? Now the thing is, it might not be quite that simple, okay? It might be where the quantity in the parentheses is some version of that base, raised to a certain power, and we'll get some examples of that right here. So example 1 says log base 2, I'm hoping you guys can see that, I'll rewrite it here, of 1 over 32. Now it might not be clear and obvious that 1 over 32 is some version of the number 2. So what we want to do is think to ourselves, how can I rewrite the quantity in the parentheses to be this base raised to some power? If we can't do that, we wouldn't ask you to evaluate this by hand. That would be something we'd need a calculator for. But we should be able to evaluate this by hand. If we think about the denominator, 32 is 2 to the 5th power. And we also know that negative exponents create that fraction 1 over that value. So 1 over 32 is 2 to the negative 5th power, which means to evaluate this logarithm, it would just be equal to the negative 5. The second example says log base 3 of 81. So again, we want to rack our brains and say, okay, can I write the number 81 as this number, similar to the base, 3 to some power? I can do that. 81 happens to just be 3 to the 4th power, which means log base 3 of 81 would just be equal to 4. Last but not least, the natural log we talked about in a previous notes video is just log base e. Log base e of e to the 1st, that's just equal to 1. All right. One more thing here, something standard that you can remember is log base b of 1 would always be a specific value. I'll give you a second to think about it. It would always be 0. Okay. Because anything to the 0 power would be 1. It doesn't matter what the base is, log of any base with the quantity 1, that's going to be equivalent to 0. All right. Now our laws of logarithms, okay, that's kind of the first thing we would do is ask you to evaluate a logarithm. The second thing we might ask you to do, and it's going to come in handy when we start solving logarithmic equations, is possibly rewrite logarithms in a different format, like taking a multiple logarithms and writing it as a single log, or taking a single log and expanding it to multiple logs, okay? The way we need to do that is by remembering our laws of logarithms, okay? So let's assume, and it's written here, that all the bases are the same. These laws wouldn't apply if we had like a log base 2 and then a log base 5 and a log base 7. That wouldn't make sense. So as long as all the bases are the same, the laws would tell us that 1 log of the quantity with multiplication involved, some value times another value, a times b in this case, is equal to 2 logs with addition. So, in theory, log base a of xy is equal to log base a of x plus log base a of y. I know it's kind of written here, but sometimes seeing it live would be the same. And this works vice versa. Okay, we'll put a double arrow there. I can take this 1 log with multiplication in my quantity and split it into 2. I could take 2 logs with addition between them and turn it into 1 log with multiplication between the quantities. All right, we also have a division law. Okay. 1 log of division turns into 2 logs of subtraction. Okay, if you want to see it live, log base a of x over y would be log base a of the numerator minus log base a of the denominator. And the last thing we get to learn is regarding constants and exponents within logarithms, okay? It is equivalent to take the quantity raised to an exponent and bring it out front as a constant. Or we could take the constant and bring it into the quantity as an exponent. We're not going to get too deep into why those things are equivalent, but they are the same. So what that means is log base 2 of x to the third just happens to be the same as 3 times log base 2 of x. Okay. See how we can drop this exponent into a constant, or we'll put another double arrow there. We could go in the other way as well. Okay. And we're going to get just a little practice real quick, condensing and expanding. Example 4 says, write these 2 logs as a single logarithm. We're condensing from 2 to 1. Okay? So, if we look at our laws, we have addition here in between our 2 logs, which means if we want to write this as 1, this is going to turn into multiplication. Okay? So we take 2 logs of the same base with addition between them, and we turn them into 1 log of the 2 quantities multiplied together. Please don't leave your answer like this. As much as we can simplify and multiply and divide, we want to do that. We actually can multiply b and b to the 5th. Our final answer here, log of b to the 6th. We condensed 2 logs with addition into 1 log where those quantities were multiplied, based on our logarithm law that we see right there. Okay. The first thing we want to do as we're condensing logarithms into 1 is move any constants up into exponents. Okay. So we don't want to start condensing when there's a coefficient on 1 log or a coefficient on any of the logs. As you can see, we don't have coefficients out front of our multiplication, addition, or division, subtraction law of logarithms. Okay, but we can move that up, so we get log base 5 of 6 squared, or that just happens to be 36, minus log base 5 of 4. Okay, if we want to write this as a single logarithm, currently we have 2 logarithms with subtraction going on between them. That's going to be equal to 1 log of division. The first quantity goes to the numerator, the second goes to the denominator, which means this is log base 5 of 9. We took 2 logs and rewrote it as 1 log. Example 5 says expand and write as multiple logarithms. Right now we have 1 logarithm. We have some division going on. We also have some multiplication going on in the numerator. Okay. So let's start by expanding this using our division rules. So right now we have 1 log of division. That should lead us to 2 logs of subtraction. So we'll have log base 2 of 5a, the numerator, minus log base 2 of 9, the denominator. We now have, if we look here, we can expand even more. We have 1 log where we have multiplication going on. We can expand that as 2 logs with addition. So this will then turn into log base 2 of 5 plus log base 2 of a, and we still have the minus log base 2 of 9. We'll get more practice with this stuff as we go, but just to recap the notes, we learned how to evaluate a logarithm. As long as we can make the bases the same, evaluating is easy. We also learned how to manipulate expressions with logarithms, okay, using our laws. Okay, we took multiple logarithms and condensed into one, or we took one logarithm and expanded into multiple.